A boat moves across a river. The river's velocity relative to the land is VRL, and the boat's velocity relative to the river is VBR. Which of the following best represents the velocity of the boat relative to the land? This is a vector addition problem, so let's say the answer is vector addition. VBR plus VRL equals VBL. Can I buy a vowel? This works out in a way reminiscent of the factor label method. Maybe we can think about positions. Your position relative to a landmark plus that landmark's position relative to your keys can help you find your keys. Or we can think about it with an example. Here's a boat and there's the river. If they're aimed in the same direction, then the red velocity of the boat relative to the river plus the blue velocity of the river relative to the land gives you the yellow velocity of the boat relative to the land. No negatives needed. The same is true if you were to point your boat in the opposite direction. You're going upstream, but very slowly. Or if you were to point your boat in a different direction, vector addition is the key.
33. An object launched and follows the dashed path shown above if air resistance is considered. That makes it harder. When is the velocity of the object greatest? When is the acceleration of the object greatest? Let's do velocity first, and it's A. That's when the velocity is greatest. You might think that the velocity at E would be pretty big too. Well, not if air resistance heats up the atmosphere and steals some of your energy, so E can get out of here. And what about the greatest acceleration while you're being shot upwards? So the air resistance is down. In the last example, you were dropped down, so the air resistance was up. Now you are shot upwards, the air resistance is down, so the answer to the greatest acceleration is A also.
At what angle to the horizontal should an ideal projectile be launched so that its horizontal displacement, the range, is equal to its maximum vertical displacement, SKIP? This is the type of problem you'd spend an entire class period working out. So you can't solve this in less than a minute and a half. But it's a solid problem. So the first step is to answer the question nobody asked. What is the hang time of this projectile? Using the first kinematic equation, the velocity in the vertical direction is 0 when you reach your maximum height 1/2 of the time through the complete trip. And we can find the hang time is equal to 2 v sine theta divided by g, the sine theta giving us the vertical component of the velocity, which is also useful when you find the maximum height. We'll call it h, plugging it into the third kinematic equation, vf squared equals v naught squared plus 2ah. Your acceleration, of course, is negative g, 9.8 meters per second squared in the downward direction. I hope you agree that there's a good value for your maximum vertical displacement h. What about the range? X equals Vx delta t. X equals V cosine theta times the hang time. I knew we were going to use the hang time, so there's our expression for the h, maximum vertical displacement, and the x, horizontal displacement. Let's set these guys equal to one another. Okay, there they are. And now we can just cross out some stuff. We can cross out a v and a v. So cross out v squared from both sides. Cross out a sine theta from both sides. Cross out a divided by g from both sides. There's a little bit of simplification. We know that sine theta divided by cosine theta is equal to tangent theta. And that would make theta equal to the arctangent of 4.